Hello everyone and welcome to this video. In this video we're going to be taking a look at how to test the SOAP web service for SQL injection vulnerabilities, which we most likely identified in the previous video. So we're now going to be building on that, and the primary objective here is not really around SQL injection payloads or the logic behind it and the techniques we're utilizing. It's more so to see whether we can get any actionable data or information from the web service via a SQL injection attack. So as I had stated in the previous two videos, this video will also be utilizing the same lab environment we've been utilizing called web services. And you can pretty much pick up from where you left off from. If you still have the lab running, it's not going to affect anything. And that's exactly what I'm going to be doing. So I'm going to be switching over into my lab environment now, and we can kick off. So I'll see you there. All right, I am back within the lab environment. And if you remember in the previous video, we identified an inkling of the SQL injection vulnerability when we were playing around with the delete user operation right over here, especially when we pretty much appended or terminated the string literal by including a single quote, which is a very good technique for testing for error-based SQL injection. And indeed, the output validated that. But the primary objective here is obviously to see whether we can extract data via a SQL injection attack. Now, in the previous video as well, I tried to see whether, whether this particular input here was vulnerable to SQL injection. And as I said, we did it by terminating the string literal. So we know that this parameter here is vulnerable. But what about the password parameter right over here? We can also test this to see whether it will work. So to begin with, I've just gotten rid of the value of a password. We didn't have one, which will bring me to another attack that you can launch here if you haven't figured it out already. But I'll send this and let's see what the response is. So you can see it says, could not authenticate account. Jeremy password is incorrect. Okay, so before we take a look at SQL injection, we can actually perform a brute force on this to try and find the password for Jeremy. But in this case, let's try the admin. Why don't we go for the big dog right over here? And this is pretty much the position. The password is what we want to brute force. So we can send this to the intruder. And there we are. There's the attack target. In terms of the positions, we're going to clear all predefined positions. And in here is where we're going to pretty much add our position. So I'm just going to add it here. And I'll add it right over here. That's where we want to add it. And we can see, yep, that's specified correctly. Now we can obviously specify the attack type as sniper, and then payloads, we can pretty much go with the word lists on the actual desktop here. So 100 common passwords, and that's pretty much it. In terms of payload processing, nothing else is required because it's being sent as a string, which is the format in which the passwords within the word list are. And we can just hit start. And again, I'm just showing you this. Okay, the host header in the request does not match the, let's go back here. That's, I think, one of my issues here. The host header does not match. So I think in this case, we would have to say demo.ini.local, and we can then start the attack. There we are. So we need to do that manually this time. And we pretty much want to monitor anomalies within the response. If we take a look at the response, we want to make sure that it's sending it okay. So there we are. These are all incorrect attempts, and we're just looking for a variation within the length of the response to see whether we find anything anomalous that could potentially indicate successful authentication. And from that point on, we would have just hit the jackpot. So this is another attack technique that you can leverage. And obviously, I'm not sure myself whether we'll get the admin password, but we'll see. We'll see. We can obviously do the same for username enumeration. So the point is that we can try and see whether we can enumerate users using a brute force attack, or a word list, if you will. But let's see whether we get anything successful. So, I can just filter by length here. Let's see. So we'll go for the longest length. And we can then scroll to the final requests being made here. I'm not sure, as I said, whether we'll get any password for this user. But yeah, this is how we would do it. Now, before, we actually haven't got any positive results, but if I just stop this attack and we'll discard this and go into the repeater, previously when we were specifying Jeremy as the username, we can see that there's something interesting going on here. It looks like usernames specified within the request need to have an uppercase, they need to start with an uppercase letter. So we can also try that just to see whether this will work. So, we can send it to the intruder. Again, I'm just showing you the various options you can explore. So the attack target is, we'll configure that manually actually. So demo.ini.local, and we'll clear the previous positions right over here, and we'll then add our position now for the password parameter. For the payloads, simple as going to the 100 common passwords.txt word list, and we can then pretty much start our attack. This will still be throttled. You do it if you do this with something like OWASP Zap, you're gonna get some seriously high speeds, especially if there's no rate limiting on the web service endpoint, which in this case I don't think there are. But pretty much just going through the same process here of monitoring for variation in the actual length. So, we can just look for any changes here. I'm going to let it reach about 60 or 80 attempts out of the 100 before we move on to the SQL injection vulnerability. All right, so I've also tried out a different word list, and it doesn't look like it's giving us anything. That could be because the admin user doesn't have the password set, or it might be set to something, a little bit hard to brute force in this particular case or context. So one more thing, obviously, I'll just show you how to repeat the process for the username. So if I go into the positions, we can perform, a brute force attack for both. However, if you remember, when we went into the repeater earlier on in the first video within this section, we can utilize the get user operation here to essentially list out user accounts, and that would essentially display the information if they exist. If not, it will display an error message. So we can pretty much just try this, and we can then perform username enumeration to see what usernames might exist, and that's another attack. And the only reason why I'm doing this is because I'm also curious as well. So what I'll do now is I'll open up a new repeater session here. And within the actual request, what do I need to modify? Firstly, I need to modify this here, because the URI, insofar as how this web application is configured, does not start from Utilidae. As for the actual username specification, that's perfectly fine there. We now need to obviously send, but it'll prompt us to enter the target details. So we'll say demo.ini.local, and I'm just sending so that I can verify that this is indeed working. Otherwise, I don't want to send any request that's not working to the intruder and then waste time with that brute force. So yeah, we know that the user Jeremy exists. Pretty much we send this to the intruder now, and we then go into the positions and we'll clear the default ones. And this is what we want to brute force. So I'll add that as a position, and pretty much the same thing repeats itself in terms of the process. We'll just load And in this case, I'll utilize a Metasploit word list that contains users. One of my favorites is just Unix users. And I'll just hit open. And this will also tell us that the user admin exists, but any other users as well will be included here. So I'll hit start attack. Okay, let me go back here. Forgot to set that up. So we need to set this to demo.ini.local. With the intruder, it doesn't do it for us automatically. So I'll just hit OK. And again, we're looking for variation in the length of the response, which you're actually getting quite a bit here. So if we click on some of these, I'm just going to open up the response here. We can see the following user does not exist. So, we pretty much can go through these and see, which ones do exist. So for admin, we can see that's 1097. We can see we get their info here. So we know that user exists. So we could have done this prior to even finding or invoking that hidden operation that would get admin info, and just use this technique. In terms of administrator, we can see that user doesn't exist. And I'm just looking for commonality. Over here, we can see these are blank. Interesting. This is, so this was no password specified, but it looks like the larger the length of the response, the more, the better the chance that it was successful. So, user Radis does not exist, so on and so forth. But, this is pretty much what we would need to do. And you then use this to sort of identify, what the valid users are. So again, also factor in the actual payload size itself, because that affects the response size, because it reflects back the username. So GNOME initial setup does not exist. Pretty much the same here. And from this point on, let's see whether we have any change in the length here. So we'll go to the highest. So admin obviously has the highest, and then payloads that are slightly longer follow suit. So this is how you can enumerate users or usernames, if you will. In this case, we don't have Jeremy in this particular word list, so I would be surprised if we did. That would be quite hilarious. So I'll just sort the length here again. And so it doesn't look like we have anything, but that's generally how you'd perform fuzzing on a web service or API endpoint to discover usernames, perform username enumeration, or perform a brute force attack on a login functionality within the actual web service or authentication functionality. So now that we've taken a look at that, we can return to the primary reason why we're going through this video, and that was for SQL injection, right? So I'll go back into the repeater here, and we'll go to our first tab here. So we know that Jeremy exists, so why don't we just stick with that user, because that is required for this operation to execute successfully. And what we need to do now is test for SQL injection, specifically the password parameter. I'm really interested about this to see whether that works. So I'll utilize the infamous SQL injection, I should say error-based SQL injection character that will, in most cases, invoke an error. So within the backend DBMS being used, so I'll hit send. So we get a 200 OK, and now you can see we do get that error. We do. So there's an exception here, and you can see that right over here under the message, it says that in the file app classes MySQL handler.php on line 194, there's an error executing the SQL query. So you may be asking yourself the question, what is the SQL query? And pay attention to this error here where it says check the manual that corresponds to your MySQL server version for the right syntax to use near the following. So we've terminated once, okay? Now that means that if I did maybe double quote, let's see what happens now. This is very interesting, very interesting. Okay, all right, so that closes it. And then if I put in a third one, again, just opening up another one, let's just see what happens. Okay, so we get an error there. So we know that this particular web service is, specifically this operation, is vulnerable to input injection or injection vulnerabilities because there is no validation or sanitization of input. So again, I'll just use the previous example. We terminate the string literal, and now we can utilize the infamous authentication bypass SQL payload or SQL injection payload, which is just to utilize Boolean-based SQL injection techniques. For example, we can say we terminate the string literal. Then after this, we can execute our SQL query. In this case, because it's Boolean-based, we'll say or, and we'll provide a logical or mathematical operation that's always going to be equal to true. The point is that when we are doing this, what we are trying to do is we are trying to pretty much execute whatever we want, and if successful, what should happen is the user Jeremy will be deleted, because if 1 equals 1 is true, then password equals true, and Jeremy will be deleted, and that's because we are invoking the delete user operation. So if you remember back in the documentation, it said that in order for us to delete an account successfully, we need to provide their valid password. In this case, this SQL injection technique will bypass the need for a password and delete the user Jeremy permanently. So how could we do this? Well, the easiest way is to pretty much take a look at the query here where it says, let's see, select username from accounts where username is equal to Jeremy, and this is where we are terminating the string literal, specifically in the password, and that makes sense because it is the final part of the query. So if we terminated earlier, it will still execute the password query here, the password check, which means we would not be able to delete the account. Actually, we might have, because that'll still work. But the bottom line is we can just put in a Boolean operation like 1, and this needs to be in strings so that we don't terminate the literal. So 1 equals 1, okay, and we don't need to close the string literal because of how this works. So I'll just hit send, and we get a 200 okay, and it says right over here could not authenticate. So yeah, I think we would need to close this. Actually, yeah, we would need to close it. That's very interesting. So we can utilize operations like this, and for example, in this case, I'll just say if we try to close it, actually this should work. This is very interesting. So if we say send, let's send and see what happens here. So we get the same error, okay, and if successful, the user Jeremy should be deleted. So I'm just going to verify that they exist here before we proceed. So okay, password incorrect, okay, no problem there. In fact, what I'm going to do is I just want to verify that this user exists, and thank you to the web service for providing that functionality, because I can now just change delete user, the operation name here, to just get user. So I'll say get user, and we'll change this here as well to get user, and we'll get rid of the password parameter. I'm just testing to see if the user exists, and if I hit send, it should tell us that Jeremy exists. So we'll say demo.ini.local, and the port here is just 80, and I will hit OK, and I will then send it. And if Jeremy still exists, then yeah, okay, so we still need to, we have not been successful. This is very interesting because if we go back into the first one here, so delete user, Jeremy, then the password, yeah, so this should work actually. If we were to put in a value here, so if I say something like test, let's just see what happens here. So yeah, okay, that's fine. So now I can say test and maybe terminate the string literal and say or 1 equals 1, but we would need to quote these here. So 1 is going to be equal to 1. So I'll just say is going to be equal to 1. We don't need to close that, otherwise that will not work. And I'll just hit send now. And there we are, could not authenticate, password is incorrect. So for some reason it's not terminating this. What if I add a comment there? This is MySQL, so we would then need to pretty much specify either a pound symbol or something like that. Still not working. Now, this means that I potentially have to analyze that SQL query because it was encoded, and I did see the inclusion of a third quote here as a mistake. So if we go back in here, so select username, etc. Actually, I want the complete encoded one. So this one here, right over here, and we want to copy this. So this would roughly translate to, yeah, that actually makes sense because that would then translate, that is encoded, so we would need to decode this. And decoding this is fairly simple. So you can see right over here, there's a third one. And what that might mean is, okay, we terminate the string literal, that then breaks it or closes the initial tag, and then we say or. Yeah, that should work. So for example, if I say or 1 1, we can actually just say 1 equals 1. Let's test this out. We don't need to close, so I'll just hit send. Let's see what this brings up. Okay, that's not possible, so we'll then iterate here a little bit. So I will then say or 1 equals 1. Okay, and then what if we included a semicolon there to terminate at that particular point? Okay, so that looks like it's working in terms of closing it up. What if we also try this particular payload for the username? So that'll terminate the string literal. We hit send, and there we are. So we put it in the username parameter, which is my mistake. Very, very interesting. So that just bypassed it completely. I forgot it was still checking for the username. So there we are. Deleted the account for Jeremy, and we earned the flag right over here. So that was actually flag 1. So very interesting. If we go back in here and see whether we can still query for the user Jeremy, it says Jeremy does not exist and verifies the fact that we were successfully able to bypass authentication here, and then of course delete the user account for Jeremy. The bottom line is this would not have worked had I not specified the username here. Okay. And by the way, if we send this as is, yeah, it'll check for a user. So we can do a lot of damage here, as you can imagine. So this is not advisable because we're now actually causing damage to property that's not ours, technically speaking, but all in the name of education. Now, another thing you can do, obviously, if you're testing for SQL injection vulnerabilities, is just fuzz with the intruder. So, for example, we'll get rid of this here, and we know that this does not exist, and we'll say admin, right? And we will get rid of this in here, and I will send this to the intruder. And if you have some good SQL injection payloads within a list, that will be a prime place to test this out. So I'll add this as the position. We can actually go into payloads, load, and we want to look for, let's see, if we do have sec lists, then that should work. But let's go up a level and into Metasploit. Yeah, that's the one we're using previously. Do we have the sec lists word list here? Let's see. We do. Fantastic. So we can now go in here, and we can go into payloads, and actually no, we want to go into fuzzing. I believe they are stored in here. There we are. And we'll go for a quick SQL injection. We don't want blind primarily, but we can say open. That's going to test for SQL injection. So we can now hit start. So if you wanted to automate the process of, sorry, I don't want to start this up here. This is going to fail. So I'll just pause this. Sorry, that's going to fail. I always want to make sure my header is specified correctly. So in here, the host demo.ini.local, and I'll just start this now. And again, we're just monitoring the response to see what it's like. So the response right over here, user admin does not exist. Ooh, interesting. Are you telling me that I deleted the admin user? Is that what you're telling me through some of the earlier techniques? Oh my God. Oh, don't tell me that we were that successful almost immediately. Let's go back to the yeah, so you definitely in the real world don't play around with operations like delete user, because they can actually delete a user account, even the admin. So if I say admin should exist. It should exist. Oh my God, we even deleted the admin username, which is not good. So I'm probably going to have to reset my lab environment. But yeah. That is how to test for SQL injection vulnerabilities on a SOAP web service endpoint. And, you know, Motilidae has some really cool examples. I think you guys should be giving Motilidae a bit more credit now. They do have other endpoints or web services here. So under SOAP, there is a SQL injection specific endpoint that has the same operation. So, you know, you can check that out there. I think it should be the same. And then, of course, we have the command injection endpoint, which is what we're going to be exploring in the next video. So that is going to be it for the practical demonstration side of this video. All right, so that was the process of testing for SQL injection vulnerabilities on a SOAP web service, specifically one that takes in input and does not validate or sanitize it. And hopefully you found that useful. As you saw, we also explored a couple of other techniques that unfortunately were not successful. But again, you know, given that this is a deliberately vulnerable web application, you know, the chance of performing user enumeration was slim. And of course, you know, we also took a look at how you can automate SQL injection with Burp Suite Intruder. And with our first attack, which did work with the intruder, it looks like it deleted the admin user. So always be that's a cautionary tale when you are performing a pen test. Do not ensure that you're not deleting data or causing damage, because I shouldn't have done that, but I wanted to show you how to utilize the intruder for fuzzing, you know, with SQL injection payload. So now that we've taken a look at SQL injection, we can now turn our attention to command injection, which, you know, is fairly simpler to identify an exploit on an endpoint. In this particular case, we'll obviously get remote code execution. With that being said, that's going to be it for this video, and I'll be seeing you in the next video.